What if I told you that in the wild, your eyes are constantly lying to you? Right now, an invisible war is being fought across the globe, not with claws or venom alone, but with a strategy of biological identity theft known as mimicry. The word itself dates back to 1637, but humans have been fascinated by it for millennia. Aristotle once wrote about how partridges use deceptive distraction displays to lure predators away from their young. One of the earliest recorded observations of what we now call Aristotelian mimicry. To understand how this works, think of it as a three-player game. You have the as mimic, the as model it copies, and the as dupes, the predator or prey being fooled. It is a system of signals and responses that can decide whether a creature finds a meal or becomes one. We usually start with the shield, defensive mimicry. In the mid-19th century, naturalist Henry Walter Bates noticed something strange in the Amazon. He saw harmless butterflies that looked identical to toxic ones. This is a Batesian mimicry, where a palatable species cheats by wearing the warning uniform of a dangerous model. The classic example is the viceroy butterfly. It mimics the vibrant orange and black patterns of the monarch butterfly. Because monarchs contain toxins that make predators sick, birds learn to avoid that specific color pattern. The viceroy survives simply by looking like it would taste terrible, but nature also has mutual safety pacts. Fritz Müller proposed a different concept in 1878, Ars Mullerian mimicry. Here, multiple dangerous or unpalatable species evolved to resemble each other. By sharing the same stop sign colors, they reduce the number of individuals lost while predators learn the lesson to stay away. It is an honest signal where everyone benefits from a shared reputation for being dangerous. However, there is a much darker side to this art, the aggressive mimicry. This is the wolf in sheep's clothing strategy, where predators and parasites use deception to get close to their victims. Take the orchid mantis, perhaps the most beautiful assassin in the world. It is a master of double, trick mimicry. Visually, its femoral lobes mimic flower petals so perfectly that bees cognitively misclassify the predator as a food source. But it goes deeper than just looks. Chemically, the mantis secretes pheromone-like compounds, specifically anip. These are the exact compounds used in the communication systems of honeybees. The mantis doesn't just look like a flower, it smells like a friend. Up in the sky, the gazelle-tailed hawk pulls off a similar heist. It is the only North American hawk that is essentially black, mimicking the shape and soaring style of the harmless turkey vulture. Because vultures are common scavengers that don't hunt live prey, small animals like lizards and mammals become habituated to their presence and don't hide when they see that specific silhouette. The hawk hides in plain sight, often soaring right alongside actual vultures. One study found its hunting success rate jumped from just 7% when flying alone to a staggering 30% when flying among vultures. Even the night sky isn't safe. Female fireflies of the genus Photurus are known as femmes fatales. They can mimic the complex light, flashing patterns of female fireflies from other species. When a hopeful male flashes his signal, the Photurus female mimics the correct response, luring him in for a mate. But when he arrives, she devours him. She isn't just hungry. She is stealing defensive steroids called lucibufagins from his body to protect her own eggs from predators. But why does this work? Why haven't the victims evolved to see through these lies? It comes down to a fascinating bit of psychology and math called the exploration-exploitation problem. Predators are constantly faced with the choice of should they be lumpers or splitters. A lumper predator treats all similar-looking prey as the same category. A splitter tries to learn the difference between every slight variation. However, learning is expensive and dangerous. If a predator eats a toxic bug, the cost of being wrong again is so high that it is mathematically safer to just lump everything that looks even remotely like that bug into the do not eat category. This Bayesian model selection is what allows imperfect mimics to survive. As long as the model is dangerous enough, the dupe won't risk testing the mimic's disguise. Mimicry isn't just an animal game either. Plants are masters of this too. Asivolovian mimicry occurs when weeds evolve to look like the crops they live among so that farmers won't pull them up. And the Espionian mimicry of certain orchids is perhaps the most bizarre. The flowers evolve to look and smell like female bees, tricking male bees into pseudocopulation to ensure the plant gets pollinated. From the deep sea to our own backyard gardens, mimicry shows us that evolution is an ongoing arms race of information. It's a world where the best defense is a good costume, and the most successful predators are the ones who can tell the most convincing lies. It's a reminder that in nature, you should never trust your first impression. Because somewhere out there, a flower is waiting to catch its next meal, and a vulture is actually a hawk, and a harmless weed is just waiting for the next harvest. If you're as fascinated by these biological illusions as I am, make sure to hit that like button and subscribe. It helps the channel grow and lets me bring you more deep dives into the weirdest corners of our natural world. Let me know in the comments, which of these mimics do you think has the best disguise? Thanks for watching.